Alrighty, gang. So today we are talking about a new unit. Okay, not like a new topic in chemistry, but a new like measurable unit, and it's called molality. It looks very similar to molarity. Okay, they look alike, and that's because they are very similar. Okay, they both measure the amount of solute into an amount of solvent into a solution. Okay, the only difference in molality is that it is moles of solute over kilograms of solvent. Okay, this and that it's denoted by a lowercase m. Okay, molarity, as we remember, is moles of solute over liters of solution. Okay, molality is important for when we are talking about our colligative properties changing. Okay, we need to talk about molality because the colligative properties that we're interested in are specifically for the solvent. Okay, so this calculation is more specific to the liquid that we are using as opposed to the molarity, which just takes into account the entirety of the solution. Okay, so molality is moles of solute over kilograms of solvent. And we need to make sure that we're looking for the lowercase m for molality. Okay, so let's do an example. What is the molality of 20 grams of CaCl2 dissolved in 200 kilograms of H2O. Okay, so first thing we need to see is that we have our solute and our solvent. Okay, the solute is CaCl2, calcium chloride, and we have 20 grams of it. So 20 grams of CaCl2. And if I look at my molality calculation, I need moles of my solute. So I'm going to convert to moles. So the molar mass of calcium chloride is 109.9, I believe, grams per 1 mole of calcium chloride. And for these T calculations that I have here, using this little T thing, I multiply the top numbers by each other and then everything on the bottom by each other, and then I divide the top number by the bottom number. And so 20 times 1 is 1. So 20 divided by 109.9 is it is 0.182. With sig figs is going to be 0.18. Actually, it's going to be 0.2, but that's okay. We'll leave it there. And that is moles of calcium chloride. And now we have, that's supposed to be 200 grams of H2O. And so we've got 200 grams of H2O. I look back at our calculation and it says kilograms of solvent, not grams of solvent. That's why I had to change that. 200 kilograms is a lot. 200 grams of H2O. I know for every 1,000 grams, there is 1 kilogram. And so multiply the two numbers on the top. That is 200 divided by 1,000 is 0.200 kilograms of H2O. And so the molality is going to be 0.18 divided by 0.200, and it should be like 0.99 something. Let's check. I'm about to sneeze. It comes out to, ooh, bless me, 0.91. With sig figs, it should be 0.9 molality. Okay, so it's a very similar calculation to molarity, but different uses and different numbers here. Okay, so make sure you pay attention to what the question is asking for, whether it's asking for molality or molarity. Okay.